but your notes close by. Let's do a quick recap, though, just because honors pre-cal recently. Oh, they were supposed to today, and we got to having too much fun with the math. We really were having fun. It was a systems of equations thing, but there are tricks, and so we were playing with the tricks and trying to figure out the tricks are always easier. We were trying to, anyway, it was fun. Their Chapter 6 test didn't go so well. For some, they did. We had over 100%. We had 2. For others, yeah, there were the lowest scores on an honors pre-cal test all year, down in the 30s. So, but wait. Well, no, wait. They had a 3x5 card, one side. Well, yeah, that's the difference. And I didn't really tell them about it until like the day before the test, maybe 2 days before the test. What have I been telling you guys the whole chapter long? You get a sheet, and it's not just formulas. You can put examples. You can put diagrams. You can, anytime I say like, oh, this would be good for the test, you can be like, I'll find one just like it and put it on my reference page. Why am I telling you that right before the word problems? No. But there's only 4 in homework. In notes, I think there's only 3. And I tell you which ones to pay super careful attention to. So what could you do on your reference page? Whole page, I'll probably do a half page front and back. A half page front and back. So it's bigger than a 3x5. Well, because what I'm thinking is when you're taking a test, like it's going to be easier to have like to see a half sheet than it would a full sheet. Like I'm thinking it'll be easier so you don't have to like keep on moving stuff all around your desk. Because a half sheet, you should be able to put it right above your desk, but a full sheet, it's going to be messy. And then you can like separate it based on sides. You can put like section 6.3 on one side and like 6.4, 6.5 on the other, or vice versa. Like you can categorize it. So let's do both sides. I like the idea of you being able to like split up things on different sides. Color coding might be good too, like based on section. But remember when we go over word problems today, if you can get good pictures down, you should be able to put it on your reference page and use it on the test. Does that make sense? Yeah. Now here's the ironic thing. Honors could have done that. And I kind of told them. But guess what most of them didn't do? Well, no, they thought they had it. And so they were being a little too confident over, you guys have done it sometimes though, right? Gone into a test a little overconfident, being like, it's easy, and then you're like, oh, smack, like that hurt, right? Yeah. So I'm trying to have you guys know what's coming better than they did. Because to be honest, I was like, I told you guys just to draw the picture, and you just have to solve the triangle. And they're like, but. So they, like a lot of them totally skipped the word problems, and that was 16 points. Like, well, or they tried something horribly wrong. And I was like, well, you put something down, I'll give you a point. Anyway, so just for you guys to know, like, pay attention today in the word problems. Don't be discouraged by them. Try to see, can I see what she's doing? Can I get a good diagram, a good solution down in my notes that I can use in homework number 1? And then I can maybe even use it on my reference page number 2. Does that make sense? Okay. So we're going to go ahead and grade homework all the way up until the 70s, all the way up until the word problems. Then we're just going to do word problems for the rest of class. And I'm going to do them very detailed, very carefully, to see if you guys can then use them in homework number 1, and then figure out what you want to put on your reference page number 2. To be honest, I think probably a smart way to do your reference sheet, if you're thinking ahead, would be section 6.3 has a whole side. I would say half of that is like the basic formulas, diagrams, component forms, linear combinations, all the stuff up into the 70s. I'd say half of one side. But I'd say the other half is just trying to get your word problems. And they're going to be categories of word problems. One's like attention, one's on a hill, and the other one is basically putting vectors together. That could be like plane and wind or speed, lots of different things. But tension, hill, and then adding together, like sum of vectors. Yeah, tension is like pulling, or it could be chains. It could be a crane lifting a box. Anyway, we'll see it today. But tension, hills, like things on the inclines like you've already kind of seen. and then putting them all together. Vector sums. All right, cool kids. So here's what I want you to do. I want you to realize today when we're grading homework, this would be half of that section 6.3 stuff. Let's grade it, have you guys ask questions on it, because some of you, you still technically have another day before we want this section done. Tonight your goal is to go ahead and finish up with the word problems too, and maybe finish up any of the questions I could answer today. Do you need to do an extra Google Classroom submission? No. But do you need to have it done by the test day? Yes. And let's strategize a little bit. When's the best time to do your homework problems? Now. Don't wait until it's like test day and you're trying to do homework from 2 sections ago, which might be focusing on little baby things that you don't need to know for the test. Or you should have already kind of figured out and now you're able to review. All right, here we go. You guys already grading? Number 2, initial terminal. Beginning, ending, initial terminal. Were they talking about points? I think, right? For a vector, the beginning and the end. Number 8, multiplication and addition. Number 14, this is what I think was given. You were just supposed to get the components by terminal minus initial. There we go. And then magnitude was take your A, take your B, take your components, Pythagorean theorem. Take your components, Pythagorean theorem. Number 22. Initial point, terminal point, the exact same thing. Subtract terminal minus initial. Plug and chug your components. Remember, if you're doing this in your calculator, you're allowed to have your calculator on this test. If you're doing this on your calculator, it won't necessarily show you the nice rationalized form on your graphers, and you probably want to use your graphers. You could bring a scientific, I suppose. But just a warning, if you don't put the negative in parentheses, it won't know that you mean -8 times -8. If you don't put the negative in parentheses, it will say, oh, you want 8 times 8 with a negative? Very different meanings. Be careful. Be careful. Put the negative in the parenthesis. 42. Unit vectors. How do I know? I see it. I see them dividing by magnitude. So take the 5 over the magnitude. Take the -12 over the magnitude. Boom, 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 done. And this was just at the very end, guys. This is just them checking to make sure it's 1 like it's supposed to be. Every unit vector is supposed to have a magnitude of 1. But the final answer is right here. 5/13, -12/13. 54, were you guys just rewriting? Oh, no. You had initial terminal, didn't you? So subtract, there's the components. What's this one called again? Components and it might be called somewhere, but not our book. Combination. Near combination form. 72. Ooh. 72. This one they gave you Despicable Me style, didn't they? Did they give you magnitude and direction? Mm-hmm. Pause really quickly, just because some of you guys might not have held on to this from yesterday. Where are we? Oh, that's not you guys. Lo siento. I apologize. There were really important formulas that we boxed at the very end of yesterday, weren't there? Or is that really awkward, like L box? There we go. How do you get components if you don't have components? Give me magnitude and direction. I got it. Magnitude, cosine, angle. Plug in the direction, plug in the magnitude, plug in the magnitude, plug in the direction. You'll have your A and B. And that's exactly what they did. These formulas are really important. Oops. Man, I can't get rid of that one. There he is. Because they plugged in magnitude cosine 90, magnitude sine 90. They threw it in their calculators and said, ha-ha, but it also makes sense. You turn 90 and you go up 4√3. Well, the point would be 0, 4√3. You weren't supposed to do 96, right? Okay. Oh, I forgot work. Oh, work is a problem too. Oh, there's the 4th one. There we go. We have tension, we have hill, we have putting it all together, and then work. That's the 4th. Speaking of which, I do want us to go back to our section. I do want us to figure out those word problems, those application problems. But really quickly, before we move on, does anybody have any evens or odds they want to ask about? Up to the 70s. Joe? 63. Anything else besides 63? Jason? 75. 39. Let's start at 39. work our way up, and if there's something else we want to grab, let me know along the way. Sorry, guys, I didn't have this on the right page yet. Section 6.3. Oh. Well, we're getting there. What page was homework on? Oh. All right, hold on, it's almost there. I should have just typed in page 4, whatever. I think the pages are a little bit off, though. That's why I do it this way. So, happy Wednesday. How you guys doing? There we go. 49, not 39? Okay. Here we go. 49's directions were find the vector. Oh, yeah, this one was a little bit tricky. I agree. Because they said the given magnitude and the same direction. The given magnitude in the same direction. And I think they want components. Does anybody have the answer to number 49? Did they want components for that guy? Oh, they did want components. Okay. Some of you guys could have just taken this guy, and you could have like actually wondered, I wonder what his magnitude is. This is just like a curiosity question that could have helped some of you. Because some of you were like, I need a formula. Show me a formula. I need a formula. Others of you were like, well, I mean 10. I wonder what that guy is. Well, if I plug him in, couldn't we have figured out that the magnitude already is 5? It's a 3, 4, 5 triangle. I just need him to be doubled. So the trick way is to say, he already has a length of 5. I need it to be 10, so I can go ahead and just say, oh, sweet, times 2, times 2. That's the trick way. Because if I double u, I will double the magnitude, and it will be what I want it to be. But is there another way? The answer is yes. The other way is you could have actually figured out the direction by using the formula that we talked about, tangent inverse of b over a. Let me go through that in my calculator because, guys, if you were to draw this vector u, what quadrant would he be in if his x is negative and his y is positive? You guys know what I'm saying for vector u? Yeah, x is negative. This is the vector u, right? Okay. So when I do tangent inverse of 4 over negative 3, uh-oh, sorry. A calculus kid used my calculator degree mode, not radian. And we get negative 53.13. Does this make sense with that picture? This is the dilemma with direction. The calculator can only give you certain answers, and you need to connect the dots to get the actual answer needed. If the calculator says negative 53.13, what do you guys need to realize is the actual angle? Not 90 plus. 180, well, 180 plus the angle, or it will end up being 180 plus a negative 53, which is minus, yeah. Calculator doesn't know any better. Calculator just spit out an angle that is negative. And it's right, but I need to add 180 to get to the right quadrant. So my direction for you is actually theta equals plus 180, 126.87. That's my actual angle. So what if I needed this guy to have that? Coterminal, it does need to end at the same place. I do need vector v to end in the same place. We could actually set up little formulas like a is going to equal magnitude. Couldn't we just have used this? We could, for vector v, we could say, well, we know v's magnitude. So we could actually find the components by plugging into our little baby formulas that I just reminded you of a second ago. We could plug in the angle, and we could plug in the new magnitude. But guess what happens? And I'll double check and make sure it's right. Because it's rounded, it's a little bit off, but guys, check it. Negative 5.9999. What would you round it to be? 6. So there's a little bit of error because we rounded that angle, but we end up in the right place. And then letter B would be when you do 10 times sine of that angle? I'm guessing so. Oh, no, 8.000. 8.0000. Yeah. So you could use the formulas or you could use logic, but not all of you. Math doesn't come intuitively to all of you. So not all of you would have gone thinking about, like, I wonder how long he is. Oh, I only need double. Okay, double him. That's a nice simple way, but if your brain doesn't think intuitively about math, it's okay. There was a formula. You could have used that to get the angle, plugged in the angle with sine and cosine and magnitude, like we saw in our notes, and then there we go. After 49 was one in the 50s. What was the 50 one? 54? Oh, no, not 54. 60s? 63 was the question? Direction angle. Ironically, what we just did will help us with this one, because didn't I just talk about tangent inverse in our notes to get an angle? And I think that's in that same little like L highlighted page that we talked about, right? Let's go back a sec. Yeah. If we need, oh my goodness, I'm drawing over my notes. If we need an angle, and this is the direction angle. So if you guys want, you can label these two. Like this one is direction, this one is magnitude. This one is the x component. This one is the y component. But using tangent inverse of b over a is what we need to do in that question from homework. So in number 63, I'm going to take my b, which is -6, right? Over a, which is 6. Now I'm putting a colon because we need to think about our picture. Guys, what quadrant is this one in with a positive x and a negative y?
4.
Yeah. So when my calculator spits out -45 degrees, is it right? Yeah, I mean, it hits there. But I don't think the book would tell me -45 degrees, because normally, I mean, it might. You guys could look at the answer. In physics-y types problems and vector type problems, I'm almost positive it would rather us go the positive way than the negative way. So even though -45, your calculator would have given you that, is right, I'm pretty sure they would rather you do 325. Does anybody have an answer to that, which one they went for? 315. Because I can't subtract, and I went fast, and I was talking and multitasking. Lo siento. But pause. Did the book go positive or negative? Okay. So use your calculator. Just remember, in physics-y, vector-y type problems, if you were needing to make it match, remember these are the same thing. They're the same place. Yeah, same thing, same place. Jason? If you're thinking in your head, the points get me to the same place, you're absolutely right. But when you ask for a direction, they're asking for the angle. Yeah, good question though. There was one more question. Let me get to the book. Number 70, what was it? 5. Okay. This was like the example we didn't get to at the end of yesterday. So let me just throw this one actually in our notes, because we had a different example. We just ran out of time. So I'm going to do this one instead. Here we go. Oh, that's awkward. Find the sum, component form of the sum. This one goes a little bit farther, but that's okay. It's the same idea. Okay, if we're trying to find the component form, this is actually a really good intro to the word problems from today, okay? This is a really good intro for the word problems from today. Remember, you're supposed to be thinking of reference pages and what are good things to write down. Do you guys see this right here? Asking us to do. But here's the problem. In order to add the two together in a picture, it actually gets really complicated. I made honors do like a whole example of it. I'm not going to make you guys do it, but can I just show it to you? Like, don't even worry about drawing this for right now. They said find the component form, and they're trying to tell us this is easier. Do this with components. That's what they're trying to tell us. The picture, if we were to actually do it, we can do this one pretty quickly. And that this one is an angle of 0 and a magnitude of 5. So there's our vector u. And then we have 5 and 90. Actually, I guess this one wouldn't be too bad to do just because the angles are easy. But we have our vector v, we have our vector u. And we also have 5. But if we were to add this one, remember, we'd actually have to take this guy, we'd have to shift him over to make it, remember, the progression of steps. And then we'd have to go ahead and think about how to connect those two. And remember, if we had lots of different steps, this picture can get really complicated really quickly. There is a way to do it with a picture. And sometimes it gets really nasty, like that one that we saw that wasn't even a triangle, it's like that weird trapezoid. Like, what are we supposed to do to fill in information if we can't even use any of the right triangle stuff, or law of sines, or law of cosines? But, well, you have to know some things with parallel lines and all sorts of stuff in order to do those. But the nice thing is you can kind of ignore that picture altogether to do this. And you can just say, who are u's components? I like them in carrots. Didn't you guys like that in homework when they were in carrots? You were like, just add. Exactly. So why don't you get them and then just add? There's a formula that says you can get this component by plugging in magnitude and direction. By plugging in magnitude and direction. Sweet. There's a formula that says, from that page that we highlighted, do that for v. All right, cool. Magnitude and direction. With sine and cosine. Magnitude and direction. I'm just stealing what they told me. And if we get the components, guess what we can do? It's as simple as that. If you can take the magnitude and directions, like the little Despicable Me guys, like, oh, that's a vector. Good, you're right. They're right. But make them components, then we can just add the steps together. So literally in my calculator, I can add down 5 cosine of 0, which I know is unit circle. We should know how to do it. But I'm being honest. You guys can use your calculators on the test. You end up with 5. 5 sine of 0 plus 5 sine of 0. No, of 90, sorry. Ooh. I get 5. So what's the sum? Vector u plus v has components of 5, 5. Well, technically for this problem, Joe, now we're done. But he might be thinking of the directions I put up above. So in this problem for number 75, you're done. But if they were to ask, if I was to ask on a test, etc., now find the direction and magnitude of the result of the overall. Anytime you see resultant, it's like after you add, after you multiply, after you. Well, then wouldn't we just use our other formulas of, oh, there's a and b. Let's go find magnitude. Pythagorean theorem. 5 squared plus 5 squared is square root of 50, which would be 5 root 2, right? And then for my angle, I would use my tangent inverse like you guys have been seeing me do. I just know it's a unit circle. That's a 1 square root of 3 over 3. 1 square root of 3. 1 goes to 45. And that matches up with my picture too. All right, those are the questions from last night. It's time for us to work on word problems. Joe.
All questions like this going to be this easy, or they're going to be something like
What Joe's asking for is that this one had 0 and 90. It was an easy one. Oh, I just stole my other example. Where's my other example? Is he back here? Oh, there he is. Long story short, Joe, they're not all this easy. But there we go. I think I have them. Oh, no, let me get rid of this guy too. Ah. There we go. If we were to have this one instead, Joe, I get that it's harder in the sense of the picture's harder. Let me go back. I get that it's harder because the picture's harder. But is the math harder? It's the exact same steps if you do what? If you go to the formulas with components. The picture is harder. You have to move the v. And what he's seeing is you have to actually put the v over here make it perfectly parallel. And if you were labeling this with geometry, let's see, this would be 50, this would be 30, this one has an angle of 30, this one has an angle of 110. The problem is with my resultant, all of a sudden, I need to solve this triangle for this unknown, and I don't even know that angle. Wait, they're parallel. Okay, they add up to 180. Cool. So this is 70. Like you could use law of, well, wait a minute, who would he be? You could use law of cosines, side, angle, side. There's a way to do it. But Joe, what did I say to do? Don't do the picture. What are you going to do instead? Do the components. Oh, they're so much easier. Because all you have to do is do 50. I don't know why it's green. Oh, because I picked up green. 50 cosine, 50 sine. And then, exactly, like you're ignoring that altogether. And what are you doing over here? 30 cosine. Got it. Yes. It's okay, it's okay. Just be thankful, yes. So then throw it in calculator and you get. Throw it in calculator and you get. But what if they want magnitude and direction? Pythagorean theorem and tangent inverse. Yeah. So it's possible. Let's do components. Sound good? And that's a great lead into vectors because, to word problems. Because word problems, it might not be nice, pretty angles. They might be messy ones. Let's start with number 89. Sorry, if you want to put the title, word problems with vectors, applications. Here we go. Tension. Not attention, just tension. Oh, no, that's fine. That's fine. And you guys, have you noticed in Google Classroom, when you hit the second tab, not the first tab, there's class resources with links to the YouTube videos, class notes, PDFs, your class calendar. Yeah, a lot of people don't go to my website. So if you're in Google Classroom, you can get there in the second. But Lauren, yeah, I'll leave it up for a sec. Just remind me with like a wave of hand if I get too distracted. Okay. Let's see if we can get through our word problems. Tension. I think in homework you have something about a pulley system and a chain and it's holding something up. Yeah, but it's holding something again. Okay, so tension, there's something being held, something being lifted. What gets tricky, well, what I think gets tricky, a few things, is that they don't start calling these guys U's and V's, even though they are. I mean, they're two different vectors. But what also gets tricky is they're measuring the angles from two very different starting points. And that can cause you some trouble, whether in homework or now. If you're measuring one angle from one direction, another angle from another direction, the math wouldn't realize that one's pulling one way and one's pulling another way. So the first thing I would do if I were you is I would figure out what one angle is in terms of the other. 44.5, sure, fine. But what would the other guy be? Not 24.3. Let's measure him the same way. So 180 minus, good, would be 157, 155.7?
Yeah.
It's the same angle. It's just measuring it the same way. It's better to have them measuring the same way than to have them measuring opposite ways. That's just kind of like a math thing. Like you usually want to use the same starting. Yeah, 44.5 is okay. Now here's the struggle of this one. I think is actually a little easier than homework. I don't remember. This one's kind of hard in that, do they tell you what the magnitudes are? Oh. They don't, right? Yeah, they tell you the overall result. Ooh. Okay, so here we go. So we have crane 1, let's call him U, just because. And then we have crane 2, let's call him V, just for their vectors. The tensions on their ropes. We have one side, we have another. They tell us what happens when they work together, aka the sum. They tell us what happens when they work together. When they work together, this crate is being held up, long story short. This crate is able to be lifted. Now, the overall result, when those two combine, and if you want, you could actually shift this guy and then blip, 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 and then see that vector up here. Is as being held up. My question is, when they combine, is this thing going side to side at all? No, it's going straight up, right? So is there any x component to the box going straight up? No. No component to it moving right to left. The box is only moving straight up. And how much force do these cranes need to be exerting to lift the box? 20,000. All 20,240 are going in the up position. Basically, the two cranes are counteracting the weight. Joe? You don't have to have more. You have to have equal.
But when you started, the moment it started, you have to have more.
No, equal. Equal, not more.
So it will remain stable and equal.
If you're not lifting the box, it's because you're exerting less force than the weight. If you're exerting the same force as the weight, you're able to lift it.
Isn't it exerting less weight than the force than the weight, it will start to go down?
No, you would have never gotten it off the ground. Joe, this would never be able to leave the ground if it wasn't exerting enough, the same amount of force as the weight. We can talk after class. Yeah, we can talk after class. So when you have the 0 and the 20,240 as the result, it had to come from crane 1 and crane 2. Had to come from crane 1 and crane 2. Now, do we know the magnitudes of crane 1, crane 2? Guess what they're actually asking for?
Tension.
Yeah, and tension are going to be, in this case, it is the how much of the force on the cables. So what we're basically trying to find is their magnitudes. So here's the crazy thing. We have the angles. We just don't have the magnitudes. But don't we have formulas that you guys saw me use a few times today? That magnitude cosine of use angle, which is what, 155.7? And then magnitude, sine of 155.7. I don't know what the magnitude is, but I know that's where it would go. If I had it, that's where I'd put it. I don't know what the magnitude is, but I know where it would go. Same thing with vector v. I don't know what his magnitude is. That's the unknown. That's what I'm trying to find, but I know where he would go. But what's his angle instead?
44.5.
Yeah. And if you guys like, we could spread this out so you can see it a little bit clearer. Because the x components combine to be the x, the y components combine to be the y. How many things are we missing?
Magnitude.
2 magnitudes. A magnitude of each vector. How many equations do we have?
3.
Kind of. We have like one big one. But don't we kind of have like one equation there?
Yep.
And one equation here?
Oh, so the thing.
But let's go ahead and make our lives a little easier. Is that okay?
Yeah.
Can we just make this equal to like x or something? And then make this equal to y? Because if we're going to have to draw or write these over and over again, it's going to be messy. So let's just go ahead and, instead of having to write magnitude, let's just do x cosine 155.7. plus y cosine of 44.5 equals 0. These two guys have to combine to be him. The horizontal components have to combine to be the horizontal components. And what's going to have to happen over here? The vertical components are going to have to combine to be the vertical component. Nope, yeah. What do we technically have? 2 equations, 2 unknowns, solve the system. What do we technically have? 2 equations, 2 unknowns, solve the system. Now guys, we technically have options right now. We just need to somehow figure out who is x and who is y at the end of the day. There is this cool thing called elimination, but to do that, we'd have to make these match. And I don't know about you, but I don't want to make them match. I don't even know what that number is. I don't know if I want elimination. There are matrices, but we haven't covered those, and it takes figuring out your calculator. Let's not do matrices. We could use our grapher. No. We could get y by itself. If we get y by itself by subtracting, dividing, wouldn't that be a line in your calculator? And couldn't we get y by itself by subtracting and dividing and do another line in our calculator? And what would we be looking for? The intersection point. That's one way, but the problem is, do you guys see how big your window would have to be? Ugh, I have to play with my zoom. So to be honest, I'm going to show you what I think is the easiest for right now with where we are in math. Chapter 7 is all about systems. We'll learn how to do this better. But for right now, you know what? I think substitution is the way to go. Substitution would say you got to get somebody by himself. So I'm going to do this fairly quickly. We're solving a system of equations. I'll zoom in. But I'm going to get, I'll get y by itself. I'm going to get y by itself. I'm going to plug in for the other y once I get y by itself. And then I'm going to solve for x. That's what I'm going to do. Okay? There are different ways of doing this. If you're like, I just don't think I can do the kind of math that I'm about to do, come on in. I can show you how to use your calculator to use like maybe a matrix to make it a little bit easier. But for right now, I'm going to get y by itself by subtracting x cosine of 155.7 and dividing the cosine of 44.5. Oops, that's not how you spell cosine. So I subtracted a big old lump and then I divided. I'm going to plug it into my other equation. That's what you always do in substitution. So I have x times sine of 155.7 plus negative x cosine of 155.7 all over cosine of 44.5. Yep. Good thing we have our calculators to do all this work for us. If anybody notices, do you see both of your x's? You can actually just get that x all the way in front, saying, okay, I'm just going to factor them out because there's a mess, but I'm just going to leave the mess. My calculator can do the mess. So I'm going to have sine of 155.7 minus cosine of 155.7 times sine of 44.5. Just a few of you might see the sine 44.5 over cosine of 44.5 and say, I could have just done tangent and only hit my button in my calculator once. Well, it's up to you. I know it's nasty, but do you guys see what I'm going to do with this big old number to get x alone? I'm just going to divide it to the other side. Because to get x alone, it's x times that big old, you could plug this in your calculator, get a big old number. It's totally fine. And you would divide it by, or you would take the 20,240 and divide it by that number. So let me go ahead and do that just to kind of show you guys. A few of you would get lost if I try to go any further as far as writing it. So right now, I am plugging this whole bleh in my calculator, just the whole thing. So sine of 155.7 minus, I'm going to use that nifty fraction button. It helps me. Cosine of 155.7. Okay, let me check it, Joe, and then we'll see if I agree. Thanks for beating me there. Okay. Some of you could see a lot easier what I'm about to do when I divide. I'm just going to divide that guy to the other side. So it's 20,240, yeah, divided by that big old decimal. I got 15,484 point, I'll do 2 decimal places, 0.9. Maybe you guys remember with systems of equations, usually when you find one, you can find the other by going back to where, yeah, he was waiting. Y equals, all I need is my x to plug in, and when I plug that guy in, negative 15,484.0937 times, what do I have, cosine 155? Some of you, it might be a good idea because you might not be able to be with us right now in your graphing calculators. It might be a good idea to maybe tonight just try with your graphing calculator first to see if you can get the same numbers I got. See if you can do, yeah, this is a good time to take a picture, Lauren, or anyone else who wants a picture. Just because I get the numbers in my calculator doesn't mean it's super easy for you. So go ahead, take these numbers, make sure your calculator would give you the same things when you plug in. All things to be double checking. But what we did is we said, okay, the tension, I need both of those to add together to hold up the box. And to hold up the box, the horizontal was 0 because he wasn't going side to side. And the weight was all in the vertical. And then I did a little baby system of equations with nasty numbers. Anybody else want a picture? Now's the time. Anybody else want a picture? Now's the time. Let's go sneak a peek at the hill. This is the other really important one as far as pictures. This is the other really important one as far as pictures. I'm going to actually give you guys a general picture. This one's not bad. It's not bad. I think it's confusing. So let me give you a picture I want you to draw, okay? Anytime you have anything on a hill, I want you to draw, let's just pretend it's down here. I want you to draw a straight vector down, a parallel vector up, and a straight vector down. You're going to need this picture. Make sure my people who are taking pictures, you're ready. My weight is going to go right down there. Force, and specifically what force? The force to keep it. Yeah, we could say to pull. To pull, to keep it from falling. In this case, that would be the combined weight of the boat and trailer would be the force. And there technically is another one down here. This one we would call the perpendicular force. But don't stress too much about him. The combined is actually right here. Force combined. Oh, you're talking about the combined weight. Sorry, the weight would be right here on the weight. The other piece that we're missing is theta. And the weird thing is theta is actually also over here. Theta is the incline. This is what most people forget. Theta is the incline. So guys, when you take this picture right here, I can actually just totally get rid of this boat picture and be like, forget you. I mean, not that he's bad, but okay, forget you. I'm going to take this and say, okay, a force of 600 pounds. Well, I know I have this triangle going down, going up, and going down. If the ramp is inclined 15 degrees, I can put 15 degrees in my nifty right triangle. If it says a force of 600 pounds is required to pull, I could put 600 right here. And if they ask for the weight, I can put X right. This isn't a crazy problem if you have the right picture, because what allows me to relate an angle with opposite and with hypotenuse? It's one of the easiest word problems if you know the picture and how to plug in. Because all I have to do to solve is, well, I actually have to multiply by x, and then divide. But 600 will be divided by sine of 15 degrees. What we did not get to do today was work. So I'm going to have you guys skip the work problem in your notes. And to be honest, I might just totally, I think work might be the next section. It might not be this section, actually. The other one we didn't get to do was combining vectors. But guys, here's a question. If they ask us to find the sum or add together a lot of vectors, do you guys think that we should draw a really detailed picture and get ready to bust out all the geometry we've ever learned? Or do you think we should just get components for everybody and say plus? That's the big thing I want you guys to take to word problems. Take this picture with the triangle. It's a really important triangle, but if you can fill in the triangle, it's actually a really easy problem. I think technically it's pounds. Yeah, pounds. But what I want you to take away to the word problems tonight when you try them is when you're trying to put lots of things together, if there are any other word problems, go components plus. Bye, guys. I'll see you in the morning tomorrow. If you have any questions, come find me. Excellent job. Excellent job. Be thinking of that reference page.